If you're looking to learn smart contract development, this is the right place to be. In this episode, we're going to walk through creating a simple bank contract. It's essentially just deposit and withdrawal logic, but it will show you some of the fundamentals on getting started, and we're going to do it in a test-driven manner using the Truffle framework. So the only real prerequisites to this are having some JavaScript knowledge. If JavaScript is totally foreign to you, this might be a little bit difficult. But if you know some JavaScript and you have some understanding of what Ethereum is, blockchains are, all that stuff, you should be good to go. This is one of our workshop series episodes, which means this is a little bit more freeform. It's not perfectly mapped out beforehand. It's me kind of just working through something for a little bit, normally around like half an hour. And we just kind of try to solve problems and talk about stuff. So if that sounds good to you, be sure to give this video a thumbs up, subscribe to the channel if you haven't, and let's jump in. What's up everyone, Steven here from TechMaker Studio. In this episode, we're going to look at some Solidity basics. To get started, I'm going to use Truffle to initialize a new project here. So if you aren't familiar with Truffle, just Google Truffle Framework Solidity or something like that, and you'll find it. We've covered it many times on the channel. So I'm going to bypass some of the explanation there, and we're just going to say Truffle init in this empty directory in my project here, and you can see that initializes a few things. We have contracts, we have migrations, we have this test directory, and then we have a config. So in this walkthrough, we're going to actually build out a bank contract. This won't be the most sophisticated thing ever, but it'll be kind of cool, and I'll show you how a number of things work. To do that, we're going to use test-driven development, which some of you may not be familiar with, but the idea is essentially that you write a failing test before you actually write a single line of code, and then you use code to make the test pass. So if we come over here to the terminal side, we can run Truffle Test, and you will see that it should be basically passing because there are no tests. There aren't any contracts other than there may be like a migration contract. Yeah. So we'll come in here into test, and we'll just write a new file, and we're going to call it bank.test.js. And you'll see really quickly what I mean by writing code that fails, and then in this test file, and then migrating to actually writing a test. So the first thing that we're going to do is say const bank equals artifacts.require, and then we'll say bank.sol, and then we'll say contract. This may actually fail already. Let's run Truffle Test here and see if this breaks. And so you can see that already we could not find artifacts bank.sol from any sources. So you can tell here that we're leaning pretty heavily on this Truffle framework because we didn't define artifacts or anything like that. It's automatically knowing how to look up in the contracts directory and find out what's in there, and then it's also going to convert that into something we can actually use in a nice JavaScript style. So what we're going to do is go ahead and come into contracts and create this file bank.sol, and basically we need to grab a couple of things, and I'm just going to copy from here, and we'll just paste these in the top of our file. So essentially you always have to declare a license identifier up here, and then we have to declare which version of the compiler we're using. I'm just going to say above 0.8.0, and then we'll write a contract bank, and then just open some curly braces like this, and we should be okay. Now let's run the test again. So you can see now I have 0 passing, but it's not breaking anymore. So it depends on how technical you want to get with the actual test-driven development process. I like this style of as soon as something is broken, you write the code to fix it. Typically, I mean, obviously if I just barely start typing here, it's going to break, so that doesn't make any sense. But like once you complete kind of an idea, so importing the file It's sort of like an idea, but once you complete that, is it broken? So anyway, to kick this off though, what we're going to do in here is declare a contract, and then we're going to say bank, and then we're going to say, let's see, how are we going to do this? We'll say accounts, and this probably needs to be async here. So this is basically just setting up our tests. So now what we can do inside of here is specify things that this should do. To save some time, I'm just going to paste in our first test here. That I just wrote this and then kind of copied and cut it. I haven't even ran this yet, so maybe I made a mistake, but it'll at least save us some time in theory. So what we do in here for the test is we write it, and then we open up a new function, which you can see here, and we say like it allows a user to deposit funds. So you're describing a function, or at least a feature of the contract. What is it allowing us to do? This is async because we're going to need to use await to talk to the chain. So the first thing we do is we say, okay, set up a new bank, saying bank equals await bank.new, which is essentially deploying a new contract to the blockchain. Now, when I say the blockchain, whenever we run Truffle Test, it spins up a little local blockchain. So you're not talking to like the Ethereum network. You're talking to something that's running on your computer that's simulating a blockchain, essentially. So we deploy that to there. I'm saying that the depositor is accounts1. So accounts, whenever we run Truffle, it will set up 10 fake Ethereum accounts on this local blockchain I was talking about and give each one of them 100 ETH. So we should be able to deposit from any of the accounts up to 100 ETH on the first time we run it. Then we have an amount, which is just using this Web3 utility to say, okay, I want to deposit 10 ETH. But in order for me to pass that number to the contract, ETH has 18 decimals, so we need to add all those decimals. So we could write like 10 and then all the decimal places behind it to get to that. But Web3 has this handy utility library, which basically says convert it to way, which is the base unit. Okay, then we run await bank.deposit, and we pass in that amount that we just set up. And we say that it's from this depositor, which as we specified up here is accounts1. Then what we do is we say let balance equal await bank.balance of the depositor. And then this one's a little bit weird to read, but basically we say convert the balance, because it's going to give us back a big int basically or something. So we're going to say convert it from way. So here we convert to way, here we go from way. So remove all those extra decimals, which should give us a number like 10, and then we should parse that into an actual integer, and then we're just asserting that the balance is actually equal to 10. So if you're not familiar with TDD, this may be super weird because we've written a bunch of code for something that does not exist. So as we run the tests, it's going to throw errors, and we're going to fix those. So let me save this, and then let's run the tests over here. And hopefully this doesn't give us any crazy surprises, but I think that we should basically be set up. So allows user to deposit funds. Error, please pass numbers as strings or to avoid precision errors. That is not the error I was anticipating. Oh, I see. I think it's wanting me to put this as a string here instead of an integer. I forgot about that. Okay, cool. I told you I probably made a mistake. All right, let's run that again and see what happens. We should be getting a message saying, hey, the deposit function doesn't actually exist. Yeah, there we go. So we have bank.deposit is not a function. So if you want to be like super pedantic, I guess is the word, about TDD, what you can do is say function deposit, and then like so on and so forth, and just run it like this, or not exactly like this. We need to do a couple of things, but you could just run it like this, but we're going to skip ahead a little bit because I can tell you that it requires arguments and so on and so forth, and we don't need to just take that level of detail here. So to write a function in Solidity, you really just write function, and then you name the function, and then you have to tell it the visibility. So is it public or private or whatever. So literally just putting public will get that little error squiggle, the little red line that was underneath to go away. And as I said, we need to accept an argument. So we're depositing an amount. And so to do that, Solidity is strongly typed, so anything that we pass in, we can't just say amount like you would in JavaScript. You have to specify what type of data this is. So we'll say uint, which is an unsigned integer, 256. There's different levels of that, but I tend to just use 256. It's the biggest possible one, which isn't always the best in some situations, but in general, that's what I go with. Okay, so now we have our function. So if we run this, we'll probably get another error telling us that balance of is not actually a function. Yeah, here we go. So now we're going to do the same kind of deal for balance of. So deposit is just something that updates the state of the contract, which we'll see in a second. So we're actually going to store the amount that's being sent in the contract, and then the other function balance of, and this one's going to basically just be a getter essentially. So it's a read-only function. So we'll say public, but we can't just say it's public. We have to also specify that it's just view only. So it's read only basically, and what it returns. So it's going to return uint 256. So that doesn't fully get us there to where we can run the test again, because we pass in the address of the user here. So we need to say address account. So you can see a few things. So we're always specifying the type. So address is a type, uint 256 is a type. We have to declare that we're returning uint 256. Let me make this a little bit wider. There we go. So if we save all of this and run it, we should actually have the error should now be like actually having to do with our actual code. So right now we've gotten like the infrastructure is kind of set up. Now it's going to say, hey, we expected to get 10, but we actually got 0. So now we have to actually implement logic. Up till this point, it was just telling us, hey, this function doesn't exist, blah, blah, blah. So anyway, now we've made it all the way down to the bottom of our test, and now we need to make the test pass. So the first thing that we want to do is actually, I just realized something. I need to pass in here the actual value. So what I'm doing here is saying, all right, so this is kind of a side note. Whenever you interact with a smart contract, you have the arguments and so on and so forth, but then there's also some other things. Like if you say value here, this is actually saying like, what's the amount of ether if you're on the Ethereum network, for example, or Matic if you're on Polygon or whatever, that you want to send along with whatever arguments and so on you're sending. So I'm kind of assuming you have some knowledge of at least like using MetaMask and things like that, sending tokens around and whatever. If you're just dealing with ERC20 tokens, you don't deal with this because that's all sort of totally within the context of a smart contract. So like we'll see more about that in a second. But this is actually really sending the native token of the chain. So in our case, Ethereum, essentially. So we're going to specify a value here, and let's run the test one more time and just make sure that this actually still passes, because we probably need to add another keyword in order for this not to fail. Okay, so that's not the most helpful error, but I think that it is happening because this is not marked as payable. Let's run this again and just see if we still get the same problem. Maybe I did something wrong, but I think that it's just because we haven't marked that as payable. Yeah, there we go. So essentially, in order to pass money, like actual ether, to a function, we have to mark that function as payable, so that it's actually able to receive that money. That money comes across in the form of message.value. Okay, so we don't need to do anything. Like whenever you send money to a contract, it's effectively the same as sending it to an address. So now at this point, the balance of the actual contract has gone up. So if we checked the actual ether balance of the contract address, it would be 10. But what we want to do is check the balance of the depositor. So we're going to have to keep track of that information somehow. To do that, we're going to have to introduce a couple of new concepts. So the first one is this idea of message.sender. So whenever somebody submits a transaction on the blockchain against a smart contract like this, whenever somebody calls a function on the blockchain, we know who sent it, so who the address is of the person who kicked this off. Okay, so what we're going to want to do is say basically like the balance of this person, and we're going to want to increase it by the message.value. And in actual fact, we don't need to pass in the amount here. Now that I'm looking at this, so we will essentially say, okay, take the balance of this person and increase it by whatever the value is that's sent. So let's go back over to our test. I wrote this kind of prematurely and didn't realize that I needed to do it like that, which is fine probably. Okay, so that basically is throwing an error because we don't have this identifier balances. So what we need to do is define this. Now this is going to introduce another concept called a mapping. And so it's not enough for us to just have like a simple data point like an integer or something like that, because we need to keep track of balances for multiple people. So that introduces this idea of a mapping where we can say, when we give you an address, give us back a uint 256, if I can type. And we'll say this is private and it's called balances, like so. And now like it's saying, all right, we have this mapping from here's an address, give us back their balance, and we have a variable name on it. So here you can see what we're doing is we're saying, okay, the balance of this person, increment it by whatever this value is. Okay, so then down here we can say return balances and then just pass in the account. Now what this means is, because we're actually passing this in via a variable like this, or via an argument, we can look up the balance of anybody. So that's all public information. So let's run this test again and see if it's passing here. I think we should be green now. Cool, so that works. Now we need to implement the withdrawal logic. Okay, so if we jump back over to our test, I'm going to paste in another test I just wrote. Okay, so let's talk through this. So what we're saying is it allows a user to withdraw funds, queuing up a new bank. My depositor is accounts 2. You don't have to change that if you don't want to. I just switched to a new account. I run through the same kind of deal as before, except for we're going to deposit 20. Then I have this withdraw amount equals 10. We're going to await bank withdraw. And then we're going to check that the balance of the depositor has gone down by 10, essentially. So we're saying check that the balance is now equal to 10. I will say up front, this isn't a perfect test. There's different approaches you could take to this. This is just a simple verification that actually the balance does go down by the amount that we're specifying. So if we run this, we'll now be failing again because we don't have a withdraw function here. So that'll be the first thing that we have to fix. And let's see what it says. Withdraw is not a function. Okay, cool. So I'm going to define this function withdraw. This one actually will take in an amount, because otherwise we would have to constantly withdraw everything, which we don't necessarily want. This one doesn't take any money, so you can't send money to withdraw. It's public. Okay, let's run this again, and then we'll see that it just fails because it doesn't actually do anything. I'm going to keep working while that's running. So what we need to do first and foremost is require that the balance of the person who's sending this message to us is actually high enough for them to withdraw this amount. Otherwise, let's say a whole bunch of people have deposited money into this contract. Anybody could just take the money that they want out of the contract regardless of their balance. So the first thing we're going to do is say require that the balance of, and I like to use my own functions when I write them, just because they're a little bit easier to read. So we'll say require balance of account is greater than or equal to amount. Okay. And actually, this is not account. It prompted me for that. It should be message.sender, which is an important point. We want to make sure that we're listening to the message sender here. So we're requiring that the balance of message sender is greater than or equal to amount. Okay. The very next thing that we want to do is say balances of message.sender minus equals amount. So we're decrementing by the amount, if I can spell balances correctly. And then what we want to do is say, first of all, if we ran the test right now, it would actually pass, which is why I said earlier this isn't quite a perfect test, but we want to go ahead and transfer the money back to our user. So the reason this will pass is because it's actually checking just the balance according to this mapping, but we're not actually checking our Ether balance. So maybe we'll do that actually. So one thing we can do is actually check the balance of the contract instead of the actual person sending the money, which sort of makes a little bit more sense to me for the simplicity of this test. We can talk about why later maybe, but anyway, so what I want to do is say let bank total balance equal, and then we'll say await, and we're going to do web3.eth.get balance, and we can say bank.address. Okay. And then we'll also do our same bank total balance equals, and we'll do web3.utils.from way and do bank total balance. Okay, so let's console log this here. If I can do this. Now keep in mind this is actually the bank, not the account holder. This is the how much money is in the whole bank. So if a bunch of people are using this is everybody's balances added together. Okay, so what I want to do is console log here. Whoop. So I'm going to do that there. I'm going to put that here, and then all the way down here after the withdrawal. Where do we run that? Okay, so let's run this. So let's just kind of quickly glance at this. So we're getting the bank balance here before we actually deposit anything. So it should be 0. Then down here we should have, okay, so I put something in the wrong place. I put this before the deposit. We want that to be after the deposit. So we'll run that one more time. So we should have 0, 20, and then 20. What we would like to see is 0, 20, and 10. Okay, and we're actually going to put that in an assert once we see that it's not working. Okay, cool. Console log is your friend. It's probably the easiest way to just kind of sanity check things. Okay, so what I want to do is say assert.equal, and we want to say that the bank total balance is 10, and I'm probably going to have to parse int this somewhere. I'll just do it here in the test. So the reason I opted to do this instead of checking the balance of the account holder is just because you have to then account for gas and so on, and I thought trying to explain that would be a little bit more complicated, whereas the bank balance actually just changes in a slightly more simple way. If you're really building this out for real, I would approach this slightly differently, but this at least gets us closer to like a real test. Okay, so let's kind of evaluate where we are in the world right now. So we're console logging all this stuff, right? So we can see our bank balance changing over the course of our interactions. We know for sure that our balance is updated like in the actual bank system. So we only have 10 left in the bank at this point for the depositor, but we haven't actually moved the funds back out. So what we need to do now is actually transfer the money back to the person who's withdrawing here. So in order to do that, what you would like to be able to do is say like message.sender.transfer amount, and that sort of would work in theory, but if we hover over this, you can see that it says send and transfer are only available for objects of type address payable and not address. So all we need to do is say, okay, this address, we want to be able to send money here, so we convert this to payable in place like this. And now we'll just transfer that amount. We'll run the test, and we should be fully passing. Okay, awesome. So you can see that we've got our bank balance changing the way that we want, and our tests are passing. So this is a really simple smart contract. This does take a little bit to get your head around some of these things, and obviously I can't cover everything in just a short video, but hopefully this was useful to you. If you like this video, be sure to give it a thumbs up and subscribe to the channel. We're going to be putting out a lot more content like this. Aiming for every day. We'll see how it goes, but we're going to be committed to bringing out some cool stuff. So all of that said, I will talk to you in the next episode.